Today we are going to learn about volumes of revolution with washers. You will be given functions on an xy plane, so where is the washer? The first thing you're going to want to do is to draw a vertical rectangle, and we're going to rotate it around the x-axis. So the solid you'll get will look something like this. So now we have two radii, a big one and a small one. So the small radius is right here, and the big radius will be right here. For the limits of integration, you typically use where the graphs intersect, and since it's with respect to y in this case, we'll be using the x-coordinates. The lower limit of integration is a, and the upper limit of integration is b. Now we're going to give you the equation to find the volume of the rotated solid about the x-axis with respect to y, just like any regular function. Integral from a to b of pi big R squared minus pi little r squared dx. Pretend that you are given the same functions, but you are asked to rotate it about the y-axis instead of the x-axis this time. So the first thing you will do is draw a horizontal rectangle, and the shape will look something like this. Now we'll find the big R and the little r. The big R is from here to here, and the little r is from here to here. And when you have the functions of the lines, you will need to change it to be with respect to x. So the limits of integration, we're using the same intersection points, and usually you just do the intersections unless you're specifically given another limit, and you can find the intersections on your calculator. So this will be from C as the lower limit to D as the upper limit. And when rotating about the y-axis, you use the y-coordinates from the intersection points. Now we're going to give you the equation to find the volume of the solid when it's rotated about the y-axis, like in the previous example, with respect to x. Integral from C to D of pi big R squared times, or minus, pi little r squared dy. Now let's try some examples. We are going to rotate this volume around the x-axis. The functions given are x, square root of x, and 1/3 x. So the first thing you'll do is draw your vertical line, and this is what the shape will look like. So the big R will be from here to here, and is the equation square root of x. And the little r is from here to here, and is the equation 1/3 x. Now the limits of integration are the same intersection points. This one is 0, 0 for the lower limit, and for the upper limit, the coordinate is 9, 3. So now let's use our equation for vertical rectangles. Integral from 0 to 9, because we're using the x-coordinates, of pi big R squared, which is square root of x, minus pi times little r, which is 1/3 times x squared dx equals 27 pi over 2. Using the same functions, we are now going to rotate it about the y-axis. So the functions that were, first we're going to draw our horizontal rectangle, and then the shape will turn out like this. So the functions that were given are with respect to y, so we're going to need to change it so it's with respect to x. So square root of x becomes x equals y squared, and 1/3 x becomes x equals 3y. So now our big R right here will be 3y, and our little r here will be y squared. The limits of integration, we're going to use the y-coordinates of the points now. So 0, 0, and 9, 3. Okay, so now we're going to use the equation for horizontal rectangles. Integral from 0 to 3 of pi big R squared, which is 3y, so it would be 3y squared, minus pi times little r, which is y squared, squared dy. And this is equal to 162 pi over 5. Sometimes you will be asked to rotate the shape around something other than the y or the x-axis. In this case, we are going to rotate it about the line y equals 4. So we're going to need to adjust our r's in this case. So we'll draw the vertical line and then rotate it this way, so your shape will look like this. And our little r will be from here to here. And our big R, our little r equals, square root of x. 4 minus square root of x, because we need to adjust it, so it's from the 4 down to the square root of x. And then the big R from here to here will now be 4 minus 1/3 x. And the limits of integration, since we're rotating it with vertical rectangles, we're going to use the x coordinates. So 0, 0, and 9, 3. So now we can plug it into the equation. Integral from 0 to 9 of pi times big R, which is 4 minus 1/3 x, squared, minus pi times little r, which is 4 minus square root of x, squared, dx. Alright, thanks for watching.